Right, well, I hope you can hear me well.
We can.
And thank you very much for inviting me to your club for this talk. As you can see, it's got Walk on there, the Warrington Amateur Radio Club. I did this talk about 12 months ago. It had additional slides because we were thinking of actually rolling this out as a club project, because a number of members were experiencing QRM, particularly on the lower bands, 80 and 40 meters. And we were thinking of actually seeing how we could improve the way that QRM could actually be managed, if that's the better word, in terms of improving our amateurs, our members' experience on the amateur bands. So I'll go through it and see what you think. So if I could have the next slide, please. Okay.
Seamless.
Absolutely.
We're back to COVID. Next slide, please.
Now, this took me back to when I was a shortwave listener a few decades ago. I bought myself I was an apprentice at the time, and I saved my money up, and I got myself an Yaesu FRB 50. And I used to have a little, I used to use my dad's shed at the bottom of the garden. I had a long wire run out to an ATU. And I used to love listening to, 80, 40 meters. And the only problem I had was the time base from the television set in the house. And by getting some ferrite rings and wrapping the coax, that drastically reduced it. And I didn't experience any other sort of interference. And with the FR50B, you could do a modification where you use the WWV band and you change it so it can operate on top band. So I did that. So I listened to the local nets as well on top band, and I thoroughly enjoyed it. And the years went by and I got my license and things like that. And I've never really returned to 80 and 40 meters until lockdown, when we were all basically at home. And everybody seemed to be on the band. So I sorted myself with a wire antenna and an ATU. Plugged it in, switched on the FTDX 3000 that I have, and to my horror, it was just absolute electrical noise right across the spectrum. Bearing in mind at that time, everybody, all my neighbours were at home, so they'd be using washing machines and all other sorts of appliances. And I've also got some neighbours who have got solar panels on their roofs as well. So that it was a little bit disappointing, unfortunately. But I did have a delta loop. That was for the HF bands 20 up to 10 meters. And that didn't seem to suffer from interference problems. Probably because most of the noise is actually centered around the lower frequency bands. But also with it being a loop and being much higher than the wire antenna, I didn't really suffer a problem. So I used the 20 meter bands and HF bands more, but I was desperate to actually get, onto the lower bands. So this was about, this was during the lockdown. So we're looking at 2020. Can I have the next slide, please? Okay then. So I thought to myself, well, let's see if we can tackle this at the source. So I rigged up a little portable radio, which has a little telescopic antenna on it, a little Sony synthesized receiver. I actually created a little loop antenna, very, very crude. But I thought to myself, well, if I'm hunting down interference, I want to be able to localize it. So I wasn't too worried about attenuation. So first of all, used a battery in the shack, switched everything off in the house, and the noise was still there. Hadn't changed really at all. So I went on, when I was allowed out to have walks, I took the receiver, and certainly for about 50 to 100 meters in radius of the QTH here, I couldn't find any changes in the interference, and I couldn't even track it down. There was nothing to point in, I wasn't walking in a particular direction, and the noise was drastically changing. It seemed to be there. So it just seemed to be in the neighborhood. So I scratched my head a little bit about this, and I did a little bit more investigation, but I thought to myself, I'm on a bit of a loser here. There's nothing obvious. With no overhead lines. Everything's underground. I live on a housing estate. I think there's something like maybe on the entire estate, something in the region of maybe 400 to 500 homes. So I came back. I was a little bit disappointed, but I started to look to see what alternatives there were. So I built myself an active receive antenna first of all. I thought, well, let's see if that does, because the FTDX3000 has a number of aerial inputs. So there's a main one, but you can switch between two others. And on, I think, the antenna 3, it doesn't transmit on it, but you can put an auxiliary receive antenna in. I thought to myself, well, if an active antenna can be turned, and I can null the interference and still receive reasonable signals, that'll get me out of the way. I had limited success with that. It did tend to reduce the noise, but it was still there, and it was competing because I was using a bit of a long wire, which I'd done my best to tune up. After a while of listening to QSOs and this noise in the background, which seemed to be repetitive and buzzing noise as well, it kind of takes a bit of a strain on you, really. You don't enjoy the experience of QSOs with the noise. Doing some searches, came across something called a QRM eliminator. So I read about this, and I thought, is this an option? This is another option. Because it was locked down, I thought to myself, what the heck, let's have a go at perhaps building one of these. So if we could have the next slide, please. Okay. So keeping it fairly simple. So what is it? And I was new to this. Well, I remember going back to my shortwave listening days that I mentioned. In Practical Wireless, they built, there was, I think in the early 70s, there's a project which was, I think, a noise processor. It was all analog. But what it did was it had a notch filter in there. And basically took audio from your receiver. And if you had like a carrier or something close to what you were tuning next to, you could actually use a phasing network, which would cancel out the noise of this of a heterodyne, for instance, or a station close by. And even though that uses a different principle, this is what a QRM eliminator attempts to do. So basically, in the simple block diagram there, you use your main antenna, which you plug in, and you have another connection which comes out of the noise cancelling unit into your receiver. There is a third connection, which is classed as an auxiliary antenna. Now, what it tends to do is, the situation is, as the diagram's showing there. So we have our main station antenna, and it includes the wanted station signal that we're looking for, plus the interference to noise. The idea of the auxiliary antenna, ideally, is just to pick up the noise and not necessarily the signal that you're after. I think the literature calls it an inefficient antenna or whatever, but its idea is, its main purpose is basically to pick up the noise that is coming in on your main station antenna. And what it does is you've got what's called phasing controls, which I'll show in a few minutes. And basically, you adjust it so that the noise coming in from the auxiliary antenna is in antiphase to the noise and the wanted to the noise coming in on your main antenna. And just using a couple of, I think they call it a long tail pair or FET transistors, they actually cancel each other out, and you end up with your wanted signal coming out to your receiver. So that's very, very quickly overview of what it does. So if we could go to the next slide, please. So whilst I was in lockdown, you can buy these, and they're reasonably cost effective. But I made this one, and it helped me just pass the time whilst we're in lockdown. So looking at the rear connections, as I mentioned, we've got looking from left to right, the auxiliary antenna. This is the one that picks up the noise. We've got the main antenna moving to the right, the cable, and the final one is the cable that will connect to your transceiver. Just below the rig connection, that's a push to talk, so you can use it with a transceiver. And the idea being is you would have this in circuit if you push to talk on your transceiver. This actually cuts the supply to the electrics within the power supply to the noise reducer canceller, and also operates a couple of relays to switch over as well. So that kind of protects the equipment. They say you can run it about 100 watts, so it certainly wouldn't be suitable for a linear amplifier, but it's there anyway, and it's powered from a 12-volt supply. Very, very simple. Looking at the front controls, those are the three main controls which you manually adjust to get the most optimum performance out of this. So the first one with the orange coloured dial with gain, that's simply a potentiometer. I think it's 1K if I remember correctly, and basically it's a resistive divider, and basically reduces your input signal from your main antenna. It's quite crude, but it seems to work. At the moment, I think it's in the 0 position, so that means that the input from the antenna is grounded in the receive mode. The next two controls, the blue and the yellow, are actually associated with the auxiliary antenna, and these are used to adjust the phase. And I mentioned that what you're trying to do with the noise is to get the noise in antiphase, 180 degrees out of sync from the noise on the main antenna, and you adjust the amplitude as well. So that's what those two controls are for. And basically, the orange one, going back to the main antenna, it is an attenuator. That's the word I was trying to. I think it's an attenuator on the main signals coming in from your main antenna. And the idea being that by careful adjusting these three controls, you can get to a position where you can reduce, and if you're really lucky, almost eliminate the noise. But as the postscript says there, it's a bit trial and error. There's no real sort of tried and tested, repeatable method of actually getting the controls. It depends on a number of factors. You know, the amount of noise being picked up by your main antenna, the effectiveness in terms of picking up noise on your auxiliary antenna, their amplitudes, etc. So it's very much station by station would adjust these. You couldn't take this from my station, take it to someone else's, and those controls would do the job. They would need to be adjusted. And we'll see some video clips coming up, and we'll focus a little bit on these controls and just try to explain what's going on there. So we've got a little switch at the bottom, which is on and off, and power. So when you switch it on, you get a little green light, which is power. And if you're using it with a transceiver and you push to talk, the red one would come on, indicating that it's not the power off to the excuse me, to the eliminator, and also switched over the relays so that the transmitter is transmitting straight through to your main antenna. Right, could we have the next slide, please? Right. So as I mentioned, my main antenna is a delta loop. It's a vertical delta loop, and it's on a mast, and this is the best one I could find at the moment for it. But you'll see that I've got a ladder feeding up to the delta loop, and I've got two other cables going up. One is to the rotator, which is an important element there, and then I've got a VHF antenna on top of that. I've played about for quite a while trying to get the auxiliary antenna to pick up the right interference. Is that the right word? No, it's not. I'm trying to select an antenna, an auxiliary antenna, by running various wires around the garden, different heights, to be an effective pickup for the noise. And I had varying degrees of success. Nothing really inspired me by this. And I was in the shack, and I was scratching my head. I was being a bit lazy, and I thought, in the rotator for the delta loop, I've got a multi-core cable, but I had 2 spare cores. So I thought, well, I wonder if that will do the job. So I clipped onto the spare cores and put it in the auxiliary, and I was surprised, really surprised with the results from this. So if we go to the next slide, please. I think this is going to be a video. And before we start the video, I thought I would just give some details of this. So let's paint the picture. I'm in my shack. This is early doors in terms of using the this noise eliminator. So I've got not really a little bench, but I've got a little working area where I set up the QRM eliminator. The rig that I've used at the time, it's a portable one, which I use portable now, which is the ICOM 706. A bit of an old lady now, but quite a nice performer. And it's using these cores, spare cores, in the main antenna rotator as the auxiliary noise pickup antenna. So I mentioned the controls running from left to right. So the orange coloured one, that's the main antenna gain, which is 8. So it's a bit of an attenuator, but you can see that being about 80% of the full rotation. So if I go to 10, then there would be the resistor attenuation would be minimal on the signal coming in from the main antenna. And the 2-phase controls, they're the ones that are associated with the auxiliary antenna. And the idea of those two is to get that phasing right and also get the amplitude of the noise right as well. So if we could try and run that first video, please. So there are 3 videos. That was the first attempt. It's about 20 seconds long. The second one is the same frequency, and basically, well, the same frequency, and it was taken about 2 minutes after this one in particular. I think the main thing that when you come to listen to it, what you'll find is that it reduces the noise on the transmissions, if I remember, by about 3 or 4 S points. but the noise is still there in terms of, but it's making the signals more readable, and I found I was able to listen to stations that weren't very strong with me because the noise level had been reduced. But as I say, the key one thing about this is that on the first and second slides, the main antenna attenuator is 8 or 8%. So quite a lot of the main stations on the main antenna are coming through quite strong. Now the third video in this sequence, I think, was taken about a week later, and it's on the 40-meter band again, but not on this particular frequency, and it lasts about 60 seconds. The noise was completely different in this case, and the noise was very, very strong indeed. I think it's something like S20 on the S meter. The antenna, again, the main one, the orange one, was set at position 1, so that's about 10%. So 10% of the signal being received by the main antenna was all that was left going through to the system. So there's quite a bit of attenuation there. And the phase settings, where we can see them being about 5 and 4 there, that's the blue and yellow bit respectively, were basically 5 and 7. So there was some adjustment. So, and what you'll find is when you watch that when the QRM eliminator switched in, the noise, which was about 20 dBs over 9, disappears entirely, which completely surprised me. And you can even hear a signal that's not even read. You can hear some a station once you've switched it in, and it's not moving. He's not moving the S meter, so the noise has completely disappeared, which I've never heard on a 40-meter band before. There's always some sort of residual noise, but that was quite interesting, and I do encourage you just to have a look at those three videos, just to see what can be done.
Golf 8 Uniform Hotel Victor. Would you like to come? Mike Whiskey 6, Golf Whiskey Oscar. In Sheffield there. I'll give you a report on the next over. Whether Glenn's got a report for you exactly, I'll hand it over to him to give you one first, and then I'll give you one on the next time. G8UHV and 088. G8UHV.
Right,
okay, so were you able to listen to that, guys?
Yeah. Well, even if you didn't listen and the video quality wasn't that good through the WebEx, but you could tell certainly in the last one, just the the level meter just dropping,
Yeah.
from this plus 20, whatever. But I'm just wondering, as a question, how much of that relates actually to the gain versus the phase stuff that you're doing? Because I think the problem that most people have, I think, with antennas, is they just have the gain turn up 100%.
Yeah. It comes out as one of my conclusions. It's all about readability, not necessarily signal strength.
Yeah.
And if you can imagine, it's if you can isolate the noise in the actual QRM eliminator and get them in antiphase, you do need to adjust the amplitudes, and sometimes, as in that final video there, you've got the gain of the main antenna signal really turned down low, because that was the point at which it balanced with the noise signal coming in from the auxiliary antenna. See, if you getting them out of phase is one of the criteria, but if the amplitudes are different, you'll only get a small reduction in the overall noise elimination. So I use I'd set up what I thought was the best combination on the two controls for the auxiliary antenna, and then adjusting. And it probably took me maybe about 10 or 15 minutes to get that combination right. So it didn't suddenly happen. It's all about these fine tunes, and some of the controls you'll find there, particularly on the auxiliary antenna, are very, very critical. Just slightly moving one of the controls, and suddenly the noise comes up. So it has quite a steep notching effect, and it's getting it into that position. So you're right. It's about getting amplitude, and yes, I've always run my radios. So I don't use them with additional gain on the receiver. So and sometimes I use basically the attenuator as well. I find those controls are far better for me in terms of listening than trying to just increase the amps on the receiver front end. Yes, it boosts the signal, but also you introduce additional noise that's created by the amps as well, and I just find it uncomfortable, and use my earring. I'd rather have low level signals with an acceptable level of noise that I can tolerate, and use my ears to pick out the signal rather than kind of ramp everything up.
Yeah, I mean, it's the old adage, isn't it? Turn the RF gain down and the AF gain up. It's not quite that simple, but I think with these, I mean, I don't want to keep holding on too long, but today's radios are just so sensitive, and I think they're oversensitive, really. Certainly the cheaper ones, and they just get overloaded so easily. I mean, I made this point, I think, during that talk on the X6100, the default gain setting from the factory is at 50%, which is really where I think most radios should be, HF radios particularly. Yeah. Whereas most of them, you just use an 857 or something like that. You don't really know where the gain setting is. You're not really thinking about it, but it's usually right up.
Yeah.
Yeah. So, and certainly you're looking at those mag loop antennas. I mean, the active mag loops, like the Wellbrooks, like the one I've got, the signal noise, the signal coming in is very, very low, but the noise is much lower. And given the sensitivity of a modern rig, that's no problem at all. It's one reason why they do work.
Yeah. And I think that the point there with interference that I was experiencing my QTH, it was mainly the electric field, the E field, that was the main problem, not the magnetic field. And I think that's where, like you said, the mag loops and loop antennas have a a better tolerance and a better performance than long wires, etc.
Yeah, I think just I don't want to labour on it too much, but I think there's sort of these old tales about long wires being noisy. I think the thing is that they're very sensitive and they can pick up a lot of stuff from lots of bands. And so when you use them, you've really got to, turn the gain down a bit. They're not noisy intrinsically, I don't think. I mean, maybe they do pick up more of the electrical field, definitely, than, say, a mag loop. But I think the problem is they pick up everything and just shoves all that through into your front end and just blows it out. So yeah, it's something I think it's not said enough is that whatever your gain setting is when you buy the rig at the maximum, turn it down to half.
Yeah.
As a rule of thumb.
Yeah, I totally agree with that, and I find it more comfortable and more enjoyable. Just having that down, and we all give 5 and 9s anyway. As far as we're concerned, as long as it's readable, which is a 5, does it matter if it's moving S3 or S7?
That's
or
absolutely
S9?
right. Yeah, I agree.
I mean, certainly from the last video, I mean, it did not make a difference, didn't it? It made it more pleasurable to listen to.
Mm.
And I think people can relate to that in a sense that, if you can remove that kind of interference, then it makes it a more pleasurable experience to actually involved.
Yeah.
Yeah, absolutely. And our hobby is about enjoyment. It is discussing and making new contacts and things like that. And and it should be as comfortable as possible. And the auditory part of that, which the noise really messes up, if we can eliminate that or reduce it to a level that's manageable and tolerable, it does make the overall experience very good. Right, okay, so we're on video 1. If you could move 3 slides, please, because the next 2 are where we're going to visit. Next one and final one. Yeah, okay. So these are my kind of takeaways, I think. Bearing in mind, as I say, if people want to use this sort of system and can get some good results from it, it's very particular to that station's conditions. But as far as I'm concerned, the auxiliary antenna is the most critical part of this. It wants to be able to pick up the interference that you are receiving on your main antenna. If it doesn't, then you'll be unable to reduce the noise overall. So it's getting it right. Ideally, as I've said, it needs to pick up the noise and not the signal. In reality, it does pick up the signal, but it should be at a lower level in terms of your main antenna. Number 2, equally important, it's all about readability, not necessarily signal strength. And certainly when you get a chance to listen to the third one, when the noise is completely removed, you can hear signals around about S1, S2, and understand them perfectly. Perseverance, I did say I probably spent about 10 or 15 minutes on that final one, trying to set up and get the best performance. But once you've got your setup with this sort of equipment embedded with your station, it'd be a case of just recording some readings and frequencies that you've used. But having said that, I had a suspicion that I was getting different interference noise from different sources. So when you tune across the band, you may come up against a piece of interference, whether it might be or very specific, which is coming from another source. You'd have to retune that system. So it's, but yeah, we're all used to plug and play, aren't we? These devices at the moment are not that. But if you're happy with one frequency and you've got it set up, you do leave it alone. Generally, it doesn't need to be touched again.
Mm.
Again, be prepared to adjust the controls. Tweak them up. Don't be put off if you get some sort of reduction in the overall noise, but not entire eliminating the noise. They are classed as QRM eliminators, which I think is pushing it a little bit, to be honest. It could be QRM attenuators, I think would be a better description. And I must admit, number 5, bit of luck there. From point of view, just thought, I'll try the couple of spare wires in the cable to the rotator, and I think that was the biggest bit of luck that I had. And but once you've got that like golden nugget of the optimum setup, you can get some very surprising and pleasing results. And that's about it. I've just got one more slide. Just if you go to that, please. There we are. Questions and comments. And once again, thank you very much for taking time to listen to me. I do apologise for suffering from a bit of a cold, so I've got a sore throat and a very nasally, so I do apologise for that. But yes, I'll try and answer any questions that you may have.
Okay, thanks, David. That was an interesting one, that, because I think we can all relate to the fact that there is plenty of noise around, but obviously there are ways around it, should we say. So any questions from the floor?
I think it's more critical if you're wearing headphones as well. Get rid of that noise.
Yeah.
What's the combination like with a battery system rather than a power supply?
I haven't tried that, but what I would say is you don't plug a switchboard power supply in to power this unit. Just use a transformer, what we call a linear power supply. But I haven't tried a battery system on that. That's a good point. That's a good point. Because if you've got some conducted interference that's coming in on your power supply, then no matter what you do with the tuning, you won't be able to get rid of it. But I found a simple transformer. It was a 12-volt unregulated transformer plugged in. Seemed to work very, very well indeed, and that's what I used on those videos.
It's all right. The reason I ask is because I've been using a battery for quite a while now, a battery system, rather than a power supply, because I find it cuts a lot of the noise out anyway. Certainly, there's a lot of power supply noise that I think most of the transformers give out, but it's significantly better already. I'm just wondering if this would be a benefit on top of that.
Well, from your experience, absolutely. We've got one of the guys at the radio club at Warrington. He's dealing with all the conductive interference he's receiving. So he's bought central ferrite rings and clip-on ferrites as well. He's replacing cables with screens on. He's just built a mains RF isolator box. So his main power comes into his shack, and he's got chokes in there as well as capacitors and that. Then he's feeding all his equipment. So he's taking care in segregating cables and signals, using ferrites and things like that. So he's really going into it in a big way, such that he was telling me that he's doing a little bit more tweaking, because I think there was something on the 2 meter band run by the SSB calling frequency, which is 144,300, I think, and he can when he moves his mouse, I think he gets this like a little whistling noise in the background.
Noise. A squeaky noise.
Yeah. So I think now that he's coping and he's got rid of a lot of noise, he's now starting to pick up like residual noise, if you see, and he's going to turn on that. So he's really driving this to practically eliminate all sorts of interference. So it's I suppose it depends how far you want to take this. And particularly most of us now have computers, computer control, and God knows where else connected to our equipment. So it is quite a challenge, trying to not for our equipment not to be the source of the interference that we're picking up on our rigs.
I can relate to that when it comes to the mouse, because when I was doing the contest at the weekend, just moving the scroll wheel on the Bluetooth mouse, could hear that through the. That sounded quiet, but everything else was really quiet. So that was the advantage of the batteries. But I was just wondering if it was if you could link these together and get something where it really improves the situation.
No, I think that's a good idea. Yeah, I think anything that is relatively easy to do and makes a benefit, I think is we should be doing it and employing it as well. Yes.
Did you get to the bottom of where the noise was coming from, or was it something that is global?
Well, I did get to the bottom of it. No, sometimes I'll go into the shack and on 40 meters it's just quiet as a bell. Or there's still some noise there, but it isn't a problem. And sometimes I come in there and it's just this buzzing noise straight across the band. I must admit I've not gone back out to find out where it is, and probably the reason is that the noise reducer has basically done that for me. You're right. You should always tackle noise at its source, but I'm kind of treating the symptoms really.
Yeah, I mean, just listen. We've had the benefit of obviously listening to the videos and the sound, but I think I can relate to some of that noise that's coming across from my own QTH, should we say? So it is potential. It is more global than anything else, but it would be an interesting scenario to carry on your investigation somewhat further to see if it could be identified as to where it came from. Because it may help other people out in the sense that if it's coming from, I don't know, a lamppost or something like that, then who knows? It could be a similar scenario around here.
Well, it's quite noisy around here, isn't it?
That's right. I mean, we always put it down to maybe the railways over there, but it's not as if you could move the railway, really, is it? But it could well be that lamppost outside is giving us a problem.
It's like Keith up on Marple Road there says to change the traffic lights to LEDs. He's had nothing but problems.
Does he know when it's red?
Yeah. Yeah, he knows when to stop and when to start transmitting. Yeah.
It'll help him cross the road.
Yeah, I put LEDs all around my house. And I've not noticed anything. Not made my noise level.
I haven't got what to look at my QT.
It'll be interesting next weekend because it's field day next weekend. I'm doing field day, and it'll be interesting because all the lights I've got for when I'm sat in the tent are all LEDs. So it'll be interesting to see what they come out with.
I think if you do everything on DC, all that stuff is run on DC. I think makes it better. But there's no alternation, no sort of harmonics.
Yeah, we don't know how the LEDs are driven. They may have choppers in there, they may not.
Even on a DC one.
Yeah, even on a DC one, if you're trying to, because LEDs, strictly speaking, are current-driven devices, not voltage-driven devices. You want to drive them from a constant current source. So, although a lot of people are lazy and they just slap a current-limiting resistor in the way, but that's quite lossy in its own way. So, I wouldn't necessarily bet that a battery-powered LED torch is noise-free.
Right.
But it shouldn't be too difficult to find out if you wave it close enough to your antenna.
Like I said, I'll find out on Saturday.
We'll try through Blackpool while the lights are on.
Sorry?
Yeah. I suppose the other scenario is, I wonder if Boeing would be interested in it, bear in mind the noise that's coming out of the ISS.
I was going to say, when it comes to, this is very similar technology to what they have in fighter jets when it comes to noise cancelling, because they have microphones by the engines and they have panels, acoustic panels, which literally transmit the out-of-phase signal so it doesn't kill the pilots.
And it's a noise cancelling headset as well. So
It's the same. It's exactly the same technology. So,
So, but I just wanted a question. I mean, I guess, how do you discriminate? How does it discriminate between noise and signal?
It's a
Because the
difference,
noise
isn't it?
cover.
It's a difference. So basically, it's like you're taking the sum and you're just taking the difference of the two signals.
Yeah.
So when you're correcting for the phase, you literally, or all you're doing is matching the phase of the two antennas,
180 degrees from each
and
other.
then all of a sudden, and that'll bring out the what else is left.
Yeah, yeah.
Do
Yeah,
you
that's-
find? I was going to say, do you find you're using the same settings on the same frequencies day to day, or do they change?
No, they don't tend to change. No, and that's I think I was mentioning, that if you if rather than scanning the band and moving around, if there are some spot frequencies you generally use, then what I would recommend is just record the frequency and the settings of the three dials for when you go there. So as long as your antenna system doesn't change, and that includes the auxiliary antenna as well as your main antenna, then you can readjust them back to your chart that says, these are the settings for 3.650 or whatever.
Okay.
Well, that would also indicate that the noise source is the same.
Constant, yeah.
And from the same direction, I would have thought.
Yeah, but I have found there's occasionally what appears, I think, to be new noise sources, and I'm not able to really make any significant reduction in the noise. So my setup works for some, but not for all. And the other thing too is that it's reasonably effective, this unit, up to about the 20-meter band. It seems to be less so in the higher frequency. Whether that's because of the circuit design, it uses toroids inside coils. Whether the inductance of those causes a problem, I'm not quite sure. But it seems to be less effective above the 20-meter band, but very effective, 80, 40, 30, and to some extent 20-meter band seems to be very good indeed.
Well, the noise is really.
Is this unit one you designed yourself, David, or is it one that you picked up from someone?
No, I can't take any credit for that. Let me think. It's on one of the panels. So if you do a search for, let me get this right, BK6 Tango November, I think he has a website showing this design. So I've actually cribbed this. I made my own board. So no, it's not my design. No, it's open source. You can find this freely on the net. I've recently bought one, primarily for the club at Warrington. The reason being is that what I want to do is quite a few of the guys do have some issues. What I was trying to do is to actually take this further and get some sort of setting up procedure that will help them to kind of make the best of it, but also to record things like, what type of interference they've got, what bands are affected, what type of auxiliary antenna they use, and a body unit that these guys can share. One can have it for a few weeks or a few months and then pass it on to the next. And then we collate that information to see if there's any common nuggets of gold or methods that we could use, that we could actually publicize further and share that with the community.
I suppose that even then goes even further in a sense that it adds it. If there's a number of you with issues, then potentially the more there you're able to identify the source of this kind of thing, especially if it's global as opposed to localized, should we say?
Yeah.
I mean, obviously we've got an issue here, and it could well be that here that kind of equipment could help us out in terms of eliminating noise from the shack here, should we say?
Well, that's certainly the main thing is, you know, do what's within your gift and what you
I can see
can.
it coming across on the
That's right.
You know,
Is your,
that's the key.
correct me if I'm wrong, did you say your antenna was a rotator? Your loop, delta loop, is it rotatable?
It is, yes.
Do you find that when you rotate the antenna that does that have any effect, or is it still
It
the
does.
same?
Yeah, it does. I've noticed that when I get it in, right, okay. So when it's got on 20 meters, it's got characteristics very similar to a dipole. Okay, it's got the figure of 8. If you look above, it's got like the figure of 8 loops.
Yeah.
When they're north-south, the noise is at a minimum. You can see it falling by a couple of S points. But my noise level is usually no more than S3 on the 20-meter band. But if I point the antennas north-south, so it's radiating and receiving north-south, it practically drops to less than S1. So yes, and not quite sure what causes that. You know, sometimes they go on and there's absolutely no noise at all. So there doesn't seem to be any pattern in terms of, you know, when I go in the morning, sometimes it's there, sometimes it's not. So it's things like that are very difficult to kind of nail down, particularly when you can't predict when they're on.
I think that may be QRM as much as QRM potentially.
Makes me
There's
wonder.
a lot of
It
stations
makes
in the
me
background.
wonder. North-south. You're in
Yeah.
Warrington. You turn it east, you know, so it's east-west, and you got Manchester and Liverpool on either side, haven't you?
And the continent and
Yeah.
America.
So whereas you go north-south, you haven't got big conurbations on either side, have you?
You've got Russia as well, that side as well.
I mean, because you know, you go up the hills here, you point it across Liverpool and Manchester, the noise goes up, doesn't it?
I'll do.
Yeah. And I think on the lower bands, particularly 80 and 40, the just thunderstorms, if they're, you know, even if they're several hundred miles away, you know, they all add to the noise floor. You know, I think that's why they say summer's more noisy than winter, because there's more thunderstorms. And if you add them all up, you do get a higher
Atmospherics as opposed to anything else, isn't it?
Yeah.
They change the atmosphere, they like change the atmospherics to subdue and for over quite a great distance.
Yeah.
It's when,
I mean, it's particularly noisy here, isn't it?
But we're in the centre of town, aren't we?
Yeah.
So maybe that adds to the issues.
Yeah.
It could be. That and the railway station.
Well, we all put it down to the railway. It may not be the railway after all.
No, it might
But
not.
then again, there's a lot of electrics going down there.
the other thing, the verticals has a low radiation angle, so it's picking up stuff laterally.
Yeah.
I think there's a good chance that the railway will have an impact on that.
I'm
I'm
sure
saying
there
that.
is.
Saying
How
that
far is the railway from here? 2 miles?
right far.
Not that far.
It's a few hundred yards up there.
I don't know.
Because it's down at the cutting, isn't it?
Yeah, they cut it, yeah.
What
It's this side of the football pitch,
Yeah.
which
Well-
is just up the road there.
where I work, we have very sensitive equipment that's very susceptible to EMF. And they built the tramway right past it, and they put loops in to try and defeat the EMF on the trams. I don't know if they do it on the trains, probably not. But they put loops in. They usually put one loop in every quarter of a mile. No, one loop in every quarter of a mile. And just on the section, I think it's the 2 mile section where we are, they put 16 in to try and eliminate it. But it's not just us, there's a massive data centre, which is also susceptible. So if the railway's done it, then it shouldn't be a problem. They probably haven't, because they've been around a lot longer than the trams have.
But I get noise off the local railway, particularly electric trains going past, diesel trains.
Yeah, I mean, you're never quite sure as to where this kind of noise is going to come
No,
from, is it?
Exactly.
Well, I
Bit
can
hard
hear
to
the train in the distance, I know it.
They're diesel electric. They're not just diesel. They're diesel electric.
Yeah. But I mean, at the end of the day, you look down the road here, the amount of KV going through the overhead wires, it's probably enough to cause enough kind of issue, isn't it?
Mm.
You know? But it is it is down slightly in a cutting. So whether that helps us out, I don't know. But you know, it's all that kind of interferences around, which, why you said if you move the antenna east-west, should we say, then you could almost see it happening with the fact you've got Manchester on one side and Liverpool on the other. Yeah.
Yeah.
Just a question on, given that you're using sort of phase differences to cancel noise out, is it assuming that the noise you're getting is a kind of beat noise? A sort of semi-regular or semi-regular?
It's Mersey beat. Sorry.
That's me, it's a little.
It's again that one. He got a mouse. Sorry.
I'm still getting over the loops in the tram.
Can I just say?
Go on, Brian.
Can I just say, no matter what we debate the noise, there's always going to be noise, and it's going to increase because everybody's got computers, switch mill power supplies. We've got more electric cars now. We've got electrical bikes or whatever it is. So we're never going to eliminate it. But like David said, if we can reduce the effect of it to a tolerable level, then we can operate. So I was thinking if we could make this as a club project. I had a quick look at the circuit diagram, and it's not too bad. It's just getting the toroids, like David mentioned. But if you could do it as a club project, I think that would be a good idea. And because I've got to go soon, to be honest. But yeah, I think a conclusion is it's a good idea to use it, and we, especially in Waltham House where it's very noisy. And if we could just use a club project, we could buy other components and get the front panel drilled, because that's always a problem these days, isn't it? If you could get all the printed circuit board built, if we could get the printed circuit board made. That would be an easy thing.
The kits you can buy.
Yeah.
On that
can buy the
PK6
complete things on eBay.
Yeah.
How is it?
Yeah.
Yeah,
they're very reasonably priced on eBay. But as a project, you know, particularly with the nights are going to be drawing in, it's something good to do if you've got soldering iron and you've got a bit of a drill and you can you know, get a decent box for it. Then it's a good project. Or if you just want to get members to buy these, and I think I bought one of these for less than £30. And I compared it with the one that I'd made, and I couldn't find any difference between it. And that one I've made is actually on a Veraboard.
Ah. So did you get any better results from one you bought, David? It was a printed circuit board, because Veraboard's got parallel copper strips. Did they conduct the interference more?
Well, I'll be honest. I'm not saying. I was surprised. I couldn't find much difference. I can't get into the box that I bought because what it is, it's sheet metal and it's got front and back plates. Okay. Now, the front plate is very similar to the picture that I showed a little earlier. But what they've done is they've glued the knobs on.
Oh God! Yeah.
So I can't go into to have a look at it. But what I have noticed, and the phasing controls, there's a little bit of hand capacity effect, and it's because you use resistors and there's an inductor capacitor network, so it's quite sensitive. I don't get that on this because it's quite thick metal. It's the box that I've got, but on the one that I bought, it's much lighter, thinner metal, and there's a slight. When I adjust the phasing controls, there's just you can hear it on the receiver, on particular 40 meters, just changing a little bit. But it doesn't stop the overall effectiveness once you've got it sorted.
So if you put your fingers on the knob, it reduces. If you take your fingers off, you get a slight difference.
Yeah, you can. Yeah, it's not drastic, but you can just detect that.
So perhaps the tuning knobs, the material you use for a tuning knob, perhaps should be taken into account. What material you use may be less subject to static or.
Yeah. But the one I bought works fine, and it works very good.
Okay, thanks very much, David. I'm afraid I've got to go now, but thank you everyone for the meeting. It's been very interesting. Thank you, David.
Okay, thanks, Brian.
Nice to see
Yeah.
you.
Cheers, Brian.
See you then.
Brian.
Bye. Bye.
Yeah,
Yeah, point there that Brian made about the material on the tuning knob. I had that problem. It was a kit that we were doing here with the courses, and I bought these knobs. You'd only got to put your fingers near it. You should have heard it. Right, flipping noise off it. Took them off, and bought another set. I didn't know. As far as I was concerned, they were Bakelite, or like a Bakelite. I put these on, nothing. So there is.
Yeah.
I suppose whether it's quality or what it was made of, I don't know. But it's. I mean, the other thing I found out was as well that if you put small knobs on, you tend to have a lot more movement. If you put a larger knob on, you've got more general control.
Yeah, that's right.
So, what's Genghis's opinion there?
Oh, I mean, basically,
Knew he meant.
I'm that old. Does anybody remember Raymond Baxter? And there used to be a thing called Tomorrow's World.
Yeah.
And going back to those days, in fact, they demonstrated one of those noise reduction things with a piston engine, where they actually cut the noise out of a piston engine, a single-cylinder engine with one of these noise reduction things, where they actually killed it completely by putting in 180-degree anti-phase noise from a speaker, actually at exactly the same. Well, basically, it was there 180 degrees out of phase, and it just kills the noise, because basically what you've got is the air pressure, isn't it? That's what we hear is air pressure on our eardrums. And if you just cancel the air pressure, then you kill the noise. I haven't actually seen the circuit to that noise reduction device you've got, Dave. I'd be interested to know how it works, because I've always had the feeling that these things tend to work at a particular frequency, a bit like a notch filter, if you know what I mean. And essentially it leaves open frequencies above and below the particular noise you're trying to kill, but maybe this doesn't work quite the same as that.
I think the design I don't think it's frequency sensitive, but it has frequency limitations, and as soon as you go up in frequency, it becomes less effective.
Right.
And I think that's due to stray capacitance, probably due to the toroidal material, etc.
Right.
But, yeah. So as I say, going back, it's taking the two noise elements, getting them to the right amplitude, getting them in antiphase, and then they cancel out.
Yeah, it was quite interesting actually when you were talking about it, because it took me back to the days when I used to be in work. I worked in a factory where we had thousands of horsepower driving massive gearboxes, reduction gearboxes, and no matter how hard you try, you cannot shut these gearboxes up, and the noise tends to get out of the factory. Never mind the amount of insulation you put in the building, it gets out of the factory and it offends the neighbors when they're trying to listen to Rimsky-Korsakov, and they've got this constant whine in the background from sort of, gearbox running it.
Rip your corsets off.
Running at 80 RPM, and a worm and pinion gears, terrible noise. And we actually, at the factory, I actually was in charge of the particular plant at the time, and I actually got a consultant in to talk about the possibility of using anti-phase noise to get rid of the problem of the neighbors. And he said at the time, you might do a bit if you had one gearbox that was particularly.
Stop sharing.
It didn't. No, the bottom line of it was, in fact, that we didn't go ahead with it because he told us we were wasting our time. Actually, that was his advice. We would spend a lot of money on the kit and it wouldn't work, which sounded kind of negative. But in this kind of circumstance, it's always worth giving these things a try. Actually,
Yeah, I think I'll give it a try. Maybe not for the for the contesting setup, but I'm certainly going to give it a try.
Yeah, I was just thinking actually that I'd like to just see the circuit that he's using actually for this. I mean, I'm quite sure with a lot of computer aid that's going on at the moment, you might be able to come up with something that was actually effective over a number of frequencies, if you know what I mean. So it would pick the noisiest parts of the noise spectrum, the background spectrum that you're hearing, and actually hit that with anti-phase noise. But I just don't know until I see the circuit.
You're all assuming that it is phase noise. It is a sort of beat noise, aren't you?
Well, yeah.
Where you use a noise blanker.
Yeah,
noise reduction.
yeah.
As
The
opposed
problem
to
is,
noise blanker.
Evan. Yeah, the problem is, Evan. Most noise is actually very random.
That's the point.
Yeah. In fact, sometimes it's not even generated outside. It's actually generated inside the equipment. And I'm not talking about mains hum or anything like that. You can actually eliminate mains hum by using antiphase, or even just large capacitors and an inductor. I mean, that's the normal way of getting rid of mains hum.
Because you have your selections on your rig, don't you? You have your noise reduction, like your Dolby stuff which was to get rid of random tape hits, wasn't it? When they on magnetic tape.
Yeah, but have you ever actually watched? Have you ever noted actually that most of these noise reduction circuits work by cutting out the high frequency part of what we hear? So the hiss, the hiss is actually high frequency random noise, and if you put in filter, capacitor, resistor circuits, which actually allow that stuff to go to ground, you will actually leave the lower frequency stuff, which in fact is more intelligible to us old guys that have got sort of low frequency hearing.
Yeah, right, okay.
Yeah.
But it's a different sort of thing, isn't it? I mean,
the kind of noise, the kind of noise reduction I'm talking about actually with that kind of simple stuff, it's very often you find in domestic radios. Well, you used to find it in domestic radios. I don't think you find it in modern ones because they can't be bothered to spend the money on it. But you used to find it in the old radios, and basically that was a kind of destructive thing. When you turned that down, you lost an awful lot of your higher frequencies. So somebody's sitting there, very carefully playing a violin, and the high squeaky notes on the violin disappear. But you still hear somebody playing the cello in the background because the frequencies are all much. It's all, why not? Yeah. Yeah, and that kind of, in fact, I would almost describe that kind of noise reduction as tone control, where tone is more frequency related than it is actually trying to kill noise.
Broadcast radio, so commercial radio, what their aims is now with DAB is noise blanking rather than noise cancelling. They'd rather have no sound instead of noise. That's what the codec, which is called Musicam.
Yes,
I did a project on this when I was at college. But the project, the codec, which is called Musicam, it's designed literally to blank the noise by cutting out completely.
Right.
That's how it works.
Right.
Right.
So it'd be interesting to see the type of circuit actually that's behind these systems.
It's not that. It's the reason DAB is awful is not because of
the bit rates are crud as
well. The reason that it's awful is because they've chosen deliberately low bit rates in order to cram as much rubbish into as small bandwidth as possible. The codec is superbly written in such a way that it can adapt and you can have immense amount of data and it stays the same. It's weird on how it's designed. It's really cleverly designed, so it can accept really high quality audio, but they've just chosen to just fire as much rubbish down as many one frequency.
It sounds a good idea. If you've got details of the circuit, then we share it with us, and then we can pass it on.
Yeah, what I'll do is I've just find it.
Musicam doesn't.
That's supposed to work very well. You need an internet connection.
Right. What I'll do, guys, for you is I'll see if I can pick up the original article. What I'll do is I'll post it onto the Dropbox page.
Yeah, okay.
Evan know.
I say just let Evan know, and then we can pick it up from there, can't we?
Yeah, I mean,
Yeah.
I've already got your stuff.
Yeah, but
Don't.
details of the circuit and stuff like that.
Oh, stuff,
On
right,
the
yeah.
BK5
I've got that, yeah.
website.
Yeah. So if you pick it up from there, then obviously we can share it around, then, can't we?
Mhm.
And maybe add it to the video as well.
Yeah.
Really edit the video. Yeah.
Yeah, and do it that way.
Yeah.
Because we can put it in the description box, things like that,
Yeah.
underneath it. But any other questions for Dave?
I think we've reached the limit.
I think we've basically
Yeah,
got
I was
the
going to
thing
say,
that we could
yeah.
bung you out, really, haven't it? But yeah, I mean, at some point in time, we'll produce a video which we can insert those cuttings, and you'll all be able to hear what you missed.
Right.
Because
Yes.
really,
Okay. Yes.
they did really help to explain the scenario, didn't they?
Yeah.
Right.
So what we'll do is we'll get the video together from this and actually insert those so you can actually see what they all are.
Yeah.
But no, it's been a very interesting evening tonight, hasn't it?
Yeah.
So
Very
Yeah.
interesting.
what I'd like
Yeah.
to say is thank you, David, for battling through.
Yes, indeed.
Yep. Hopefully you recover from this soon. And I can see by the clock behind you, it's ticking past 9 o'clock. So
He'll be back in 2 months.
Yeah.
Mate.
yeah, he's
Going
back
past
in
bedtime.
6 months. Yeah, that's right. I won't give out any spoilers, but it's about a box. So there you go.
Yeah.
There you go.
Black box.
So
Yeah.
any final comments, Dave?
No, but I would think, thank you very much for taking time to come down and listen to me waffling on. But seriously, noise is a big issue for us, and a number of you have said it's only going to get worse.
It will. Yeah. Try.
And this is something that can help us to manage that. So yeah, it's been a pleasure and an honour really to present this to you, and thank you very much for listening. You'll see the ICOM 706 again when I do something about this box, which is early November, I think. So I'll see you then, if not sooner.
Yes, indeed. And I suppose we better introduce Stephen. You keep seeing his hands coming in.
Hi, Steve.
His arms are keep appearing every so often.
We've phased Stephen out.
Yeah, we phased Stephen out. That's right. Yeah. But thanks, Dave. It's been a real pleasure, and it's been a pleasure for us as well.
Thank
and
you.
It's been great to see you, and we'll wish everybody at Warrington well, and hopefully we'll meet up soon at some point in time.
Yeah.
Along the way, but certainly in November, obviously, as far as yourself is concerned. So have a pleasant evening there, and thanks for coming along, giving us an interesting talk.
Yeah,
Absolutely.
See you.
Thank you.
Yeah,
Guys,
yeah, yeah.
73s.
73s. Cheers. Yep.
See you soon.
Look.
Hello.